Section 4.4, exponential and logarithmic equations. So in this section, it kind of ties everything from chapter 4 all together. So you're going to see we are going to do some problems that you've seen before, and then we're going to relate that to new types of problems. So this should be good practice of the entire chapter. Example 1, solve 8 to the x equals 32. Now if you recall back, we did problems like this. Okay, and the way we solved those was we got the same base. So I'm going to show you that method, and then I'm going to show you another method. Now, 8 to the x equals 32. I cannot rewrite 32 as 8 to some power, so I have to use a smaller base. So what I'm going to do is I'm going to convert the 8 and the 32 to a base 2. So 8 is 2 cubed. So I have 2 cubed to the x equals 32 is 2 to the 5th power. Well, I know that this is 2 to the 3x, the multiplication rule for, or the product rule for powers, is equal to 2 to the 5th. Once I have the same base on each side, I can take the powers, so 3x is equal to 5, and set them equal to each other. Solve for x, I get x equals 5/3. Now that is the old way we solved it, and that still works, but I'm going to show you another way. If I were to take this exponential equation and rewrite it in logarithmic form, it would look like this. Log base 8 of 32 equals x. Okay, so again, I can check by doing the loop. 8 to the x power equals 32. All right, so I did set it up right. Now, in the last section, I learned change of base formula. So I can rewrite this as log of 32 divided by log of 8. When I type that in my calculator, I get x equals 5/3. So now you have two ways to solve the same problem. Example 1b, we're going to solve 2 to the negative x plus 1 equals 16 to the 5x. Again, this is a problem where I can get the same base on both sides. So 2 is the lowest I can go, so this is still 2 to the negative x plus 1. And I know I can write 16 as 2 to some power. In fact, it's 2 to the 4th. So I'm going to write it as 2 to the 4th raised to the 5x. So on the left-hand side, I have 2 to the negative x plus 1 is equal to 2 to the 20x. I just multiply those two powers. Now I have the same base. I have base 2 on both sides. If the bases are the same, then I know the powers must be equal. So negative x plus 1 must equal 20x. I'm going to solve this by adding x to both sides. That gives me 1 equals 21x. I'm going to divide both sides by 21, and I get x equals 1 over 21, and that is my answer. So if you can get the same base on both sides, I think that's the easiest way to approach these problems. If you can't, we'll look into alternative methods. Solve 4 to the x minus 5 equals 1. So this is another problem where I'm going to show you two methods. Okay, so the first method is to try to get the same base. Well, this is a base 4 and this is 1, and you're like, how do I do that? Well, what power of 4 is going to give me 1? All right, so I can rewrite this as 4 to the x minus 5, and I know the only way I'm going to take 4 and raise it to a power and get 1 is if that power is 0. So I have 4 to the x minus 5 is equal to 4 to the 0 now. Bases are the same, so I can set my powers equal to each other, and I get x minus 5 is equal to 0, which means x is equal to 5. Now sometimes you look at that and you're like, I don't know where to start. I don't realize that 4 to the 0 is equal to 1. So let's look at it another way. Like I did on the first problem, let's rewrite this in log form. Okay, so that's going to be log base 4 of 1 is equal to x minus 5. And again, I can check with the loop. If I loop again, it's 4 to the x minus 5 equals 1. So I set it up correctly. Now I have change of base formula. Change of base formula says I can rewrite this log base 4 of 1. And I can rewrite it as log of 1 divided by log of 4 equals x minus 5. I'm trying to solve for x, so I'm going to add 5 to both sides. I'm going to add 5. So that gives me log of 1 divided by log of 4 plus 5 is equal to x. When I plug in log of 1 divided by log of 4 in my calculator, I'm going to get 0. 0 plus 5 is equal to x, so x equals 5. Okay, again, two methods for you to look at for the same problem. Still looking at this example of 4 to the x minus 5 equals 1, we're trying to solve it. I'm actually going to give you one more method. Okay, to solve this, we're going to take the log of both sides. So I'm going to rewrite that as the log of 4 to the x minus 5 is equal to log of 1. Now the power rule says I can take this power and put it out in front. So now I have x minus 5 times log of 4 is equal to log of 1. I'm trying to solve for x, so I'm going to divide both sides by log of 4. And I'm going to rewrite that as x minus 5 is equal to log of 1 divided by log of 4. Add 5 to both sides. That gives me x equals log of 1 divided by log of 4 plus 5. If I put log of 1 divided by log of 4 in my calculator, I'm going to get 0. So that's going to give me x equals 0 plus 5, which again gives me x equals 5. So now we've looked at this problem and we've seen 3 different approaches. Keep in mind that many problems have different approaches. Okay? And it doesn't matter necessarily which way you approach it, just whatever makes sense to you. Example 1D, solve natural log of x equals 12. Well, when I see this, I always want to rewrite natural log as log base e, so I can see what the base is. So log base e of x equals 12. Now, when it's in log form, I can always convert it to exponential form, so I'm going to do my loop. And I'm going to rewrite that as e to the 12th equals x. Well, I've solved for x. It doesn't ask me for a decimal answer, so I'm going to leave it as e to the 12th. And you're going to see if you plug e to the 12th in your calculator, you'll get a decimal. Now, if it asks for a decimal, then go ahead and plug it in. Now, I want to look at this one more way. Natural log of x equals 12. What is the inverse of natural log? Well, that is e. So I'm going to do e raised to the natural log of x on the left-hand side, and I'm going to do e raised to the 12th on the right-hand side. I know that natural log and e are going to cancel out, and that's going to leave me with x equals e to the 12th. Okay, so 2 ways to look at the same problem. Example 2, solve and then round each answer to 4 decimal places. Again, I'm going to show you a couple different methods, and you choose which works best for you. So we have 3 to the x equals 5. The first thing I'm going to do is I'm going to rewrite this as a log function. Okay, so I'm going to write this as log base 3 of 5 equals x. So again, if I check my loop, that gives me 3 to the x equals 5. Okay, so I took this exponential function and rewrote it in log form. That allows me to take this log base 3 of 5 and use the change of base formula to rewrite it as log of 5 over log of 3 equals x. Then I can simply type in log of 5 divided by log of 3 in my calculator and round it to 4 decimal places. So that's going to give me x is approximately equal to 1.4650. All right, again, that's one way to solve this problem. Let's look at it another way. If I have 3 to the x equals 5, 3 to the x equals 5, what I can do is I can take the log of both sides. So I'm going to write it as log of 3 to the x equals log of 5. Now that allows me to use the power rule and pull this power of x out in front. So that's going to leave me with x times log of 3 equals log of 5. I'm going to solve for x, so I'm going to divide both sides by log of 3. And that gives me x is equal to log of 5 divided by log of 3, which we know is equal to 1.4650. So again, two ways to approach it. It's just however you visually see it and understand it. Example 2b, solve 2 to the 2x plus 3 equals 15. My approach, again, we have two approaches. I prefer to rewrite this in log form. Okay, so I'm going to rewrite it as log base 2 of 15 equals 2x plus 3. So again, you can check your loop. 2 to the 2x plus 3 is equal to 15. So I have it set up correctly. Now I can use change of base formula on the left-hand side to write this as log of 15 divided by log of 2 is equal to 2x plus 3. I'm trying to solve for x, so I'm going to subtract 3 from both sides. That leaves me with log of 15 divided by log of 2 minus 3 is equal to 2x. Then, to get x by itself, I'm going to divide the whole thing by 2. So x is equal to log of 15 divided by log of 2 minus 3, all of that divided by 2. Okay, and again, the directions were to round to 4 decimal places. So that is the exact answer, but since it tells us to round, I'm going to go ahead and type that in my calculator, and I'm going to get x is approximately equal to 0.4534. Okay, so again, type that in your calculator, make sure you're getting that. If you're not, talk to me in class and we'll figure it out. Solve 4 to the 1 minus x equals 6 to the x. Now this one's a little bit more involved because we have an x on the left-hand side in the exponent, and we also have an x on the right-hand side in the exponent. So you could rewrite this in log form, but you'll see that you kind of get a little stuck. So what I'm going to do is I'm going to take the log of both sides. Okay, remember what you do to one side, you have to do to the other. So I'm going to rewrite this as log of 4 to the 1 minus x. Whoop, that should be 1 minus x. Is equal to log of 6 to the x. Now, once I have it rewritten like that, I can use my power rule that says take this power of 1 minus x and throw it out in front of the log. So that's going to give me 1 minus x times log of 4 is equal to, same thing on the right hand side, I can use the power rule to take this x and drop it out in front, is equal to x times log of 6. Okay, now again, my goal is to solve for x, but I have x on both sides. So you have a couple options. Okay, what I'm going to do is I'm going to distribute this log of 4 to both the 1 and the x. So that's going to give me log of 4 minus x log of 4 is equal to x log of 6. All right, I'm trying to get my x's on the same side, so I'm going to add x log 4 to both sides. So that leaves me with log of 4 on the left-hand side is equal to x log 6 plus x log 4 on the right-hand side. Now notice they both have an x in them, and we're trying to solve for x. So I'm going to factor out a greatest common factor, which happens to be x. So now I have log of 4 is equal to x times log of 6 plus log of 4. Now, to get x by itself, my last step is going to be to divide both sides by log of 6 plus log of 4. So I'm going to divide this side by log of 6 plus log of 4. At this point, I know I'm trying to get a decimal answer, so I can take and type in log of 4 divided by log of 6 plus log of 4 in my calculator, and that's going to leave me with x is equal to 0.4362. Example 3. Solve 2 plus log of 3x minus 4 is equal to 5. And I have a little reminder up here, don't forget to check. And when I say don't forget to check, remember, I'm telling you to remember that you cannot take the log of a negative. If it's going to let me write, let's see. Log of, I'll write down here, of a negative. You cannot take the log of a negative. So that is what we're checking for. So let's go ahead and start solving this problem. I'm trying to get x by itself, so I need to move everything else to the right-hand side. So the first thing I'm going to do is subtract 2. So that leaves me with log of 3x minus 4 is equal to 3. Now I know if no base is written, that means the base is 10. So this goes back to what we were doing in section 4.2. To solve this, I'm going to go ahead and do the loop. That's going to give me 10 to the third power is equal to 3x minus 4. Now I'm solving a basic two-step equation. Well, 10 to the third power is equal to 1,000. So I have 1,000 equals 3x minus 4. I'm going to add 4 to both sides. So I'm going to write that over here. I have now 1,004 is equal to 3x. I'm going to divide both sides by 3. And that gives me x is equal to 1,004 divided by 3. Now, when I say check, I want to plug that number into the log, what I'm taking the log of. So I'm taking the log of 3x minus 4. When I plug that in for x, I just need to make sure that what I'm taking the log of is not negative. So 1,004 divided by 3 times 3 is 1,004. 1,004 minus 4 is 1,000. So I'm taking the log of 1,000, which is okay. So I'm good to go on this example. Solve log of x squared minus 6x plus 9 equals 0. Again, if no base is written, we know that it's a 10. So I'm going to do my loop to rewrite this. I'm going to rewrite it as 10 to the 0 power is equal to x squared minus 6x plus 9. Now I need to solve this. 10 to the 0 power, well, anything to the 0 power is 1. So now I have 1 equals x squared minus 6x plus 9. Notice that this is a quadratic. So to solve a quadratic, I want to get everything on one side. So I'm going to subtract 1 from both sides. That's going to leave me with 0 equals x squared minus 6x plus 8. So now we're back to what we were doing at the beginning of the semester, factoring quadratics. All right, to factor this, please take some time and pause it if you need to and factor this on your own before we proceed. This factors to 0 on the left-hand side equals, I can factor it to x minus 2 times x minus 4. All right, the zero product property says if I have two factors and they're equal to 0, that one of those factors must equal 0. So I'm going to take x minus 2 and set it equal to 0. I'm also going to take x minus 4 and set it equal to 0. That gives me x equals 2 and x equals 4. But remember, I have to check. So what I want to do is I plug 2 into this, into x squared minus 6x plus 9 back here. And when I plug that in, I get a positive value. Also, when I plug in 4 into x squared minus 6x plus 9, I get a positive value. So that tells me I'm not taking the log of a negative. So my answers are both x equals 2 and x equals 4. Example 3c. For this problem, we're going to solve log of x minus 4 plus log of x plus 5 is equal to 1. Now notice what's different about this problem is we have two separate logs. So before we can really proceed to solve for x, we need to combine this or condense this into one log. So we're going to condense, which goes back to what we did in section 4.3. I have two logs with the same base. They're both base 10, and they have addition between them. Addition between them means we're going to combine them using multiplication. So I'm going to rewrite this as log of x minus 4 times x plus 5. Okay, again, I'm combining them. Since there's addition between, I know that these two pieces are being multiplied, is equal to 1. Now, with that, I'm going to go ahead and FOIL the x minus 4 and the x plus 5. So that's going to give me log of x squared plus x minus 20 is equal to 1. Now again, I know that the base is 10 even though I'm not writing it. So I'm going to go ahead and do my loop now. 10 to the first is equal to x squared plus x minus 20. 10 to the first is equal to x squared plus x minus 20. Well, 10 to the first is just 10. So I'm going to subtract 10 from both sides. So that leaves me with 0 equals x squared plus x minus 30. This is another quadratic, so I need to factor this to solve. So when I factor, I get 0 is equal to x plus 6 and x minus 5. When I set each of those equal to 0, so I have x plus 6 could equal 0, and x minus 5 could equal 0, and I solve those, that leaves me with x is equal to a negative 6 or a positive 5. But remember, I have to go and check. So let's check the negative 6. Right off the bat, when I put a negative 6 in here for x, that leaves me with log of negative 10. Well, I can't take the log of a negative, so I know that the solution x equals negative 6 is not going to work. But let's check our 5. When I put 5 in for x, I get 5 minus 4, which is okay. And I get 5 plus 5, which is okay. So my only solution for this problem is x equals 5. 3D, solve log base 7 of 5x minus 2 minus log base 7 of 3x plus 4 is equal to 0. So just like the last one, we have two separate logs, so we need to condense them. We have subtraction between the two. So subtraction means we're going to condense them and use division. So these are log base 7, so I'm going to have log base 7, and it's going to be division. So it's going to be 5x minus 2 divided by 3x plus 4 is equal to 0. So again, condensing is back in section 4.3. Now to solve this, I'm going to do my loop. 7 to the 0 is equal to 5x minus 2 divided by 3x plus 4. So 7 to the 0 is equal to 5x minus 2 divided by 3x plus 4. Anything to the 0 power we know is 1. So 1 is equal to 5x minus 2 divided by 3x plus 4. I'm going to multiply both sides by this denominator. The denominator is 3x plus 4. So I'm going to multiply that on the right-hand side and the left-hand side, 3x plus 4. On the left-hand side, 3x plus 4 times 1 is simply 3x plus 4. On the right-hand side, it's going to cancel out because I have it in the numerator now and the denominator. So that's going to leave me with 5x minus 2 on the right-hand side. Now, I'm back to just a basic linear equation. I'm going to go ahead and solve by getting my x's on one side and my constants on another. So I'm going to rewrite it over here. 3x plus 4 equals 5x minus 2. I'm going to go ahead and move my x's to the right. So I'm going to do minus 3x. That leaves me with 4 equals 2x minus 2. I'm going to add 2 to both sides. That gives me 6 equals 2x. Divide both sides by 2, and I'm left with x is equal to 3. Now remember to check. So I'm going to go up and make sure I'm not taking the log of a negative. Well, when I plug in 3 into 5x minus 2, it doesn't give me a negative, so we're good to go. And when I plug in 3 into 3x plus 4, it doesn't give me a negative, so again, I'm good to go. So this checks out. My answer is simply x equals 3. Example 4, solve by substitution. We did substitution way back, okay, the first half of the semester. So we're looking at substitution again, but we're going to use substitution when we're dealing with exponential functions. So the first thing I'm going to do is I'm going to rewrite this equation so that you can see where the substitution is coming from. So right now I have 8 to the 2x minus 8 to the x minus 20 is equal to 0. I'm going to rewrite it as 8 to the x squared minus 1 times 8 to the x minus 20 is equal to 0. And I did that so that you can see I have 8 raised to the x and 8 raised to the x. Once I have those the same, I know I can do my substitution. So I'm going to say over here to let u equal 8 to the x. So I'm going to take out those 8 to the x's and put the u in its place. So that's going to become u squared minus 1u minus 20 is equal to 0. So we'll come back to that 8 to the x later. But now that I've done the substitution, you can see I have this nice quadratic equation. I have u squared minus 1u minus 20 equals 0. If I wanted to solve that, I would factor. So to factor this, it becomes u minus 5 times u plus 4 is equal to 0. So I'm going to go ahead and solve this. So u minus 5 could equal 0, or u minus 4, plus 4 could equal 0. That tells me that u could equal 5, or u could equal negative 4. But remember, going back up here, we said let u equal 8 to the x. So I have to go back to that. So down here, I don't really have u equals 5. I have 8 to the x is equal to 5. And same thing over here with u equals negative 4. I don't have u is equal to negative 4. I have 8 to the x is equal to negative 4. So I still need to solve for x. So let's do it one at a time. I have 8 to the x equals 5. You have several ways you can solve it. I'm going to rewrite it in log form. So I'm going to write it as log base 8 of 5 is equal to x. And then I'm going to rewrite this using the change of base formula as log of 5 divided by log of 8 is equal to x. If it wanted a decimal answer, I could go ahead and put that in the calculator, but since it doesn't say to put it in decimal form, I'm going to leave my answer exactly as log of 5 divided by log of 8. Now over here, I'm going to do the same thing. I'm going to rewrite it. So I'm going to rewrite it as log base 8 of negative 4 is equal to x. Well, I know that I cannot take the log of a negative number, so this piece is not going to work. So I just have this one answer, log of 5 divided by log of 8.